Okay, today we're going to be looking at Chapter 8, Topic 5. This is a couple-day topic because there are a lot of different things to cover. We're looking at graphing rational functions. The first type of rational function we're going to be graphing is in the form y equals ax plus b over cx plus d. Okay, so we got both the x's, both of them are linear. So the numerator is linear, the denominator is linear. The steps to doing this: find the vertical asymptote. Vertical asymptote will be the value that makes the denominator equal to 0. Now it's going to be a vertical line that the graph doesn't cross. We're going to find the horizontal asymptote, which is equal to y, which is a over c. Okay, whatever a is over whatever c is. We're going to plot that asymptote. Find the y-intercept by substituting 0 for x, and find the x-intercept by substituting 0 for y. And then we'll plot all of that. We'll choose 3 values smaller than the vertical asymptote and 3 values larger than the vertical asymptote that we will plug in and evaluate to create a table. We'll plot those points, and then we'll determine the domain and range. So the first one we want to do is 2 over x. Now, keep in mind, if we want this in the form ax plus b over cx plus d, this is linear, okay? We can think of this as 0x plus 2 over 1x plus 0, okay? We can think of it this way if we need to use this form, because we are going to need a, b, c, and d. Okay, so the vertical asymptote, start with the vertical asymptote first, which means we'll be setting the denominator equal to 0. So the vertical asymptote is just x equals 0. So that's going to be a dotted line that this graph does not cross, up and down, vertical, and it goes through 0. Horizontal asymptote is going to be y equals a over c. A is 0, c is 1, so that's just 0. Okay, so that's going to be right here. So these are our asymptotes. Next, we'll find the x-intercept. To find the x-intercept, you plug in 0 for y. So if I plug in 0 into this equation for y, I would have 0 equals 2 over x. Multiply both sides by x, and we get 0 equals 2. Okay, so 0 equals 2, that doesn't make any sense. We don't have an x-intercept. You can kind of tell, since they're asymptotes, we're not going to, and there is an asymptote on the x-axis, we're not going to have an x-intercept. So there is no x-intercept here. The same thing's going to happen for the y-intercept, okay? Y-intercept means plugging in 0 for x. Well, if you plug in 0 for x, you get 2 over 0, which is undefined. Okay, so there is no y-intercept, and that is because there's an asymptote on the y-axis. All right, now, so to do this, to do our table, which is next, we are going to do 3 values to the left of the vertical asymptote and 3 values to the right. Okay, so to the left of it, if our vertical asymptote is 0, to the left of it would be -1, -2, and -3. And then 0 here, but remember there's nothing for 0, so you don't have to fill in anything for 0. And then to the right of it is 1, 2, and 3. So we're going to plug in each of these values into the equation and evaluate. So let me go to a blank page. So we got y equals 2 over x, and first we're going to plug in -3. So y equals 2 over -3, or -2/3. The first one is -2/3. Next, we'll plug in negative 2. So we got y equals 2 over negative 2, which is negative 1. Next, we'll plug in negative 1. So y equals 2 over negative 1, which is negative 2. And then we'll move to 1. So we'll plug in 1. So y equals 2 over 1, which is 2. We'll plug in 2. So y equals 2 over 2, which is 1. And we'll plug in 3. So y equals 2 over 3, which is just 2/3. Okay, so we're going to plot each of these points. So we first has negative 3 and negative 2/3, which is right here. We have negative 2 and negative 1, and then we have negative 1 and negative 2. On the other side, we have 1 and 2, we have 2 and 1, and we have 3 and 2/3. Okay, so here's what these look like. We can kind of see their curve. They should approach the asymptotes in both directions. So here gets close to the asymptote. Over here gets close to the asymptote. Over here gets close to the asymptote. And over here gets close to the asymptote. Okay, so this is what our graph is going to look like. The domain, okay, if we follow the domain starts at negative infinity, and then it goes to 0, but it doesn't actually get to 0. So it moves to 0, and then it stops. It doesn't actually get to 0. And then it starts again over here at 0, and then moves to infinity. Okay, so the only thing that the domain is not is 0. Okay, 0 is the only number not in the domain, and that's because there's an asymptote here. So we say that we have the union of these two intervals, okay, this interval and then this interval, and the union of the two represents the domain. The range is similar, okay, it comes up from negative infinity and approaches 0, and then it starts again at 0 and goes up to infinity. Yeah, the only value that's not in the range is 0. Okay, let's look at the next one. Negative 5 over x. So remember, if you're looking at this, I would put this negative up here with the 5, honestly. It doesn't really matter, actually. If you're looking at this as a linear 0x minus 5 over 1x plus 0. Okay, just so we can see our a and our b. So our vertical asymptote, we set the denominator equal to 0, so x equals 0. Nothing to solve there. So that's going to be right here. Horizontal asymptote, y equals a over c. Okay, so a is 0, so this becomes 0. For the x-intercept, plug in 0 for y, but that's an asymptote, so there is none. For the y-intercept, plug in 0 for x, but once again, asymptote, so there is no y-intercept. Okay, so we need 3 to the left and 3 to the right. This is almost just like the previous problem, okay? So 0, there's no value for 0, negative 1, negative 2, and negative 3, 1, 2, and 3. So we're going to plug in to their equation for each of these values. So y equals negative 5 over x. We'll start with negative 3. So y equals -5 over -3, which is just 5/3. Next, we'll plug in -2. So y equals -5 over -2, which is 5/2. Now, if you need to plot these, you may want to write them as decimals so that you know where they are plotted. So, like, for example, 5/3. 5 divided by 3, that's 1.6. And then for the next one, 5/2, that's 2.5. And then -1, -5 over -1, that's just 5. And these are all going to be the same. They're just going to have a opposite sign. So -5, -2.5, and -1.6. Okay, we'll go ahead and plot these. So we got -3 and 1.6. We got -2 and 2.5. And we got -1 and 5. Over here, we got 1 and -5, 2 and -2.5, and 3 and -1.6. Connect these to make our curves, and this one looks like this. They should always approach the asymptote, and this one looks like this, and it approaches the asymptote. Domain, everything except for 0, so it's -infinity to 0, and then it picks up back again at 0 and goes to infinity. Same thing for the range, it's everything except for 0, so it goes from -infinity to 0 and from 0 to infinity. Sometimes this is written as all real numbers, just that x and y can't be equal to 0. Okay, our next example, x minus 2 over x plus 1. Vertical asymptote is whatever value makes the denominator equal to 0. So that would be -1. So that's right here. The horizontal asymptote is going to be y equals a over c. So in this case, 1 over 1. A is 1, c is 1. So y equals 1. It's going to be right here. Whoops. Horizontal, sorry. It's going to be right here. For our x-intercept, we plug in 0 for y. So let's take our equation and plug in 0 for y. So we have y equals x minus 2 over x plus 1. So if we plug in 0 for y, we get 0 is equal to x minus 2 over x plus 1. Multiply both sides by x plus 1. We get 0 is equal to x minus 2. Add 2 to both sides. X is equal to 2. So our x-intercept is 2. Y-intercept, plug in 0 for x. So we get 0 minus 2 is -2. 0 plus 1 is 1. So we get -2. Put those points on our graph. So 2 and -2 on the y-axis. Okay, good. All right, and now for our table, we need 3 values to the left of the vertical asymptote, so left of this and to the right of this. So to the left of this, it's at -1, which has no value, -2, -3, and -4. To the right of this is 0, 1, and 2. All right, so we'll start with the first one, -4. So y equals -4 minus 2 over -4 plus 1. -6 over -3, which is 2. Next is -3. So y equals -3 minus 2 over -3 plus 1. -5 over -2, which is just 5 halves, which is 2.5. And then -2, -2 minus 2 over -2 plus 1, which is -4 over -1, which is 4. On the other side, plugging in 0, we actually know what we get when we plug in 0. We already did it, but we'll do it again. Y equals 0 minus 2 over 0 plus 1, -2 over 1, which is -2. If you haven't noticed, these do end up being symmetrical. We plug in 1. All right, my pen crashed, so y equals x minus 2 over x plus 1. We're plugging in 1. Y equals 1 minus 2 over 1 plus 1, which is -1 over 2, or -1/2. Yeah, -1/2. All right, and plugging in 2, 2 minus 2 over 2 plus 1, which is 0 over 3, which is just 0. Oh yeah, where are my intercepts? So I had an x-intercept at 2, a y-intercept at -2. Okay, so now let me plot my points. So I have -4, 2, -3, 2.5, and -2, 4. On the other side, I have 0, -2, which is already there, 1, -0.5, and then 2, 0, which I already have because those were the intercepts. Now I can connect these to make my curves. They should approach the asymptotes. Approaches the asymptote here. This one approaches the asymptote here, and this one approaches the asymptote here. Domain is everything except for 0, so it's from -infinity to 0. Oh, sorry, not 0, sorry. Domain actually is everything except for -1, because it gets close to -1. So -infinity to -1, as well as -1 to infinity. For the range, it's +1. So -infinity to 1, and 1 to infinity. Okay, so for the assignment here, we have page 113, number 3, and page 114, numbers 1 and 2. You can ignore this right here, or actually just doing this for homework.